PCB layout based on the schematic we just made. Go to open your schematic file. In our case, this one. Okay. Now all your components will appear. First, we will make a board outline. So go to Objects, Board Points. Then create a round rectangle board. Width 50, height 50, radius 4. Now move it over a bit. Okay. Now we will create some mounting holes. So select mounting holes here. Put one down. Modify it to the normal diameter of a mounting hole, which is 3.2. It will fit most common mounting hardware. The diameter is 5 or 6, depending on what mounting hardware you use. Put one down, put another one down. Move over your components to the left side, so you can place these two mounting holes again on the bottom side. Okay. Now we will work on the layout of our components. First, our chip has to be upright, so with the circle on the top left corner. So press space. Now it's okay. The grid that we are working on is currently 1 mm, but we want it to be the same as the pin spacing on our IC, and it was 0.65, so we will modify it to 0.65. Okay, and then we want all our components to snap to that grid that we just made. So push Ctrl A, Options, Snap to Grid by pads, and now everything will be on the same grid, which is nice and easy to work with. So now we will place our components. It's a bit tricky. I already did this layout once, so I know where most components should go to create as short traces as possible. It's really a skill. You have to do it and do it and do it over again, just to get a feeling of what should go where and what's the best layout. In this case, this one can go here. This one can go here. If you pick it up, you will see the traces that are relevant to the component. These blue lines aren't really called traces, they are called red lines. Once you select trace or route manual, it will ask something. Just press OK. If you go from pad to pad, what is put down, that is the trace. And that's the physical connection that will be on the board once it's manufactured. Now we will just put it down here. This one goes there. As you can see, these capacitors have stripes because we just used the general ones from the main library. It's not really relevant here because these capacitors are not polarity dependent. If you see these capacitors here, these are polarity dependent. If you wire them up the incorrect way, they will let some smoke out and they won't work anymore. These on the output will be simple ceramic capacitors which don't have a polarity. Put down this here. Okay, then we will move these ferrite beads. These were ferrite beads. You can see R5. It's labeled as a resistor because we use the resistor in schematic. But we just use this resistor in the schematic because that one has the same pattern as the ferrite bead we'll be using. If you double click it, you can see the pattern is 1206, which fits the ferrite bead we're using. It's just that the name doesn't comply with what we are actually using. So put it down, put that one down here. It's almost impossible to get the place just right in the first try. You have to move them around after you've placed them. If you want to recheck if there are shorter connections possible to the pins, you have to press F12. Yes, F12. and then it will recalculate the shortest paths, those blue red lines. If I press F12 now, it will create the shortest path between the components, which is handy once you've moved everything around and the shortest path aren't the same anymore. Okay. As you can see, they say board edge here, which doesn't match with our board outline once it's placed. But if you create your own terminals with your own patterns and symbols, you can just leave that out. And if you create your own, it's better to create a bigger terminal because the current through this is a bit too large for these simple connectors. But this is just for the tutorial, so don't worry about that. Okay, now you can see this one goes through that one to that, so we can place this one here. These one all need to connect to this pin, so we can route it through here, and then it will have a short trace. This one goes through there. Select route. If you go from here to here, just by accident my trace width lines up with the pin width on the chip, but if it doesn't, you can check which one does. In our case, the chip pins were 0.3 millimeters, so you can put the trace width at that, and it's handier to do that via route net classes and then change it to 0.3 here. If you press OK, all traces you will be making from now will be 0.3 millimeters, so it will match the pin width on the chip. It's best to leave as much spacing between the traces as possible. Now we are done with the output section. As you can see, I used thick traces where possible, especially in the output path of the amplifier, because that's where high currents will be flowing. Now we will go on to the input section. This is the gain setting part, the resistor divider with the capacitor, the ground. We can use thin traces here because these aren't that critical, these aren't high current paths. Now we have put our components into place, and this seems to be a fairly good layout. Yeah, these needs to be a bit closer, but first we'll have to transfer the whole layout to the board to see how it would fit, where the connector needs to go. So select everything and place it over here. These output terminals need to be right up against the side of the board. And now we can see where these can be placed, so that the input terminal can also be on the side of the board. And now, as you can see, it's very difficult to get these pads connected to the rest of the pads, so all the pads that light up red now. This is the ground path, and since our bottom layer will be ground, we can just use a via for that. The via is a through-hole connection that connects the top layer with the bottom layer, or just any layer with another layer. as you can see, most red lines are replaced with real traces. Now we will place our decoupling capacitors and input power pins. The small ones are for the high frequency decoupling and need to be the closest to the pins. As you can see now, they don't connect to the pins, but they light up red. So they are connected, but if you press F12 I mean, it will just choose the shortest path, and now they are connected. They can't be too close to the chip because otherwise it will be difficult to solder, but they need to be fairly close. The middle pad is connected to ground. To do that, you can just route a trace to the pad, and now it's connected. Or you can select add to net and select by mouse pointer on from list. Then you can do it manually. Now the big bulk capacitors. You can place these here, you can place these here. It's just a matter of preference. This seems okay. Now on the other side, press F12 to refresh to red lines. Okay, so now we have to draw a trace from these red pads to the other side, but we can't without crossing any other traces. So we'll have to draw a trace underneath the PCB, so on the bottom layer. Switch layers by pressing 2. Now you can draw a big layer, or a big trace, 4 millimeters in my case. And now they are connected. All other traces are routed too. You can see these aren't connected, but they don't need to be connected because this pin will be connected via the ground plane. Now we will create a set of vias to connect the thermal pad to the bottom layer, which will act as our heatsink. Go to place static via, place 1, copy it over. It's nicer to work on a fine grid because once you'll place them, it's easier to get them aligned. But first we will have to connect them to the correct net. So go to add to net, select the vias, select them to net 4 to ground. Okay, so now if you place them here, DIPTRACE will know that the pads and the pad and the via are from the same net, so they won't separate or create errors. Now we will put down our ground pour. Go to the bottom layers by pressing 2. Place upper pour. Click, enter. Use the net clearance. It's a bit bigger than the custom clearance here. Use a solid fill. Connectivity, go to net 4. So it will be connected to ground. Thermal relief, 4-spoke 45s, it's just for easier soldering. Border, snap to outline. Okay. And now these will just be one big plane. So if the IC, the chip will generate heat, it will pull through the vias to the bottom layer and it can dissipate from there because this is one big copper plane. As you can see, the power trace is from a separate net, so it isn't connected. It has a small clearance all around it. Same goes for the terminals, output terminals, input terminals. If this was a single-ended board, the middle pin would be referenced to ground, but now it's wired as a differential input. Okay, so now we are almost finished. We just need to touch up on some things. For example, this chip, let's rename it to TPA, just so it looks nice. Now the board is almost finished. We can just put some details on it. For example, right and left are labeled correctly, but the input won't be printed if it's outputted like this. So take it and put it here, for example. Now you can just check via verification design rules if there are any errors. Yes, there are. This one is too close to the edge, so you can put it back a couple of steps. Run it again. They are gone. And this one is too close to the edge, so put it back a bit. And now it's okay. 2 more errors, probably on the bottom layer. Yes, because we've pulled it back and we haven't refreshed the copper pore. It will give you an error. So go to Objects, Update Copper Pore, run DRC again, and no errors found. In the next chapter I'll tell you how to 3D preview your board so you can check for visual errors. If there aren't any, you can go on to the next step, which is outputting to a Gerber file. So you have a file that you can send to the board house, then they can produce your board. Since our board is only 50 by 50 millimeters, we could even make it smaller if we want. But since it's so small, you can go to Seed Studio or iTeeth or another Chinese PCB manufacturer. You can get 10 made for $10, which is a great deal. And they'll ship it to your house in about a couple of weeks, maybe a couple of months, depends on the time of the year. Let's not forget to connect C5 and R2 to ground. We can do that with a via. You can place a static via and then connect that via to ground. So add to net from list, and net 4 was ground, so connect it to net 4. And then you can use a trace a bit smaller than that. To connect it to ground. And now these traces will go to the via will go to ground via the bottom side via the copper port. And if you want, you can put some text on your board, like your name or the name of the design, the revision of the board, by going to this one, ABC, and then typing something, clicking and typing. For example, and then you can double click it. It has to be in the top silk. If you want it on the top at least, you can also put text on the bottom. Top silk, it will turn the same color as the other top silk lines. And if you want, you can change the font to another size.